Hello everybody, this is Nikhil Pratap Bhanate from University of Florida. I'm doing a project called Automatic License Plate Recognition and Record Retrieval using the OCR technique. This is part of a course called Image Processing and Computer Vision. Let's see what the project is about. So this is how the presentation is structured. We first go into the overview of the LPR system, what it actually is and what it does. After we know what the LPR system is, we define the objective of the project. And then we go on and look into the OCR technique which is used for this particular project and some of the techniques which were developed for the pre-processing stage of the project. Finally, we wrap up the whole presentation with the results in the demo part. So ALPR is actually a system where it autonomously captures the images of the number plates and then processes these images, and then it recognizes the license plates of the vehicles. We have an input image which is like this. So this input image is given to the ALPR system. The ALPR system processes it, and then it recognizes the license plate and retrieves the record from the database. So this finds application in a lot of fields. So for example, in law enforcement, obviously it finds a lot of applications there. In the toll booth automation, surveillance operations, assisting in traffic enforcement, automatic parking and ticketing system. So these are some of the applications in the real world where the LPR system is used. So this image on the right hand side shows the conceptual overview of the LPR system. So we have a car and we take an image of the car and we separate the number plate of the car from the whole image of the car, and then we recognize the characters inside the number plate. Using this number plate we retrieve the record of the vehicle, which is shown like this. So what ALPR actually does is it transforms the images into alphanumeric characters. So this is done using the OCR technique in this particular project. So when this OCR technique recognizes the characters, it is woven into a string, and using this string the vehicle record is retrieved. So there are three major steps in the ALPR system. First is the capturing of image. This can be real time or also it can be offline. It can be retrieved from a database, etc. Second step is image segmentation. So image segmentation is the process where it just retain the interesting part of the images. In our case it is the number plate image. And the third is character recognition. So when we have the number plate image, we have to recognize the characters which is inside the number plates. That is the last step of the ALPR flow. So the captured image is consisted of noise elimination and pre-processing. So noise elimination is obviously really important because in the outside environment noise is a very big problem. So it has to be eliminated. This is part of the pre-processing stage as well. And pre-processing, as we will see, is processing the input image so that the input to the character recognition module is as ideal as possible. Plate extraction and character segmentation are the parts of the image segmentation process. So we have to extract the plate from the number plate and then segment the characters inside the number plates. Template matching and record retrieval. So when we have these individual characters, we match the characters to the templates which are predefined, and when all the characters are matched to the templates, we get a string, and using the string we retrieve the records in the database. So objective of this project is to develop a ALPR system, but the emphasis of this particular project will be on the pre-processing stage. So this particular project uses the existing OCR algorithm and makes an improvement on the OCR part of the algorithm. What we focus on is pre-processing stages. So our assumption here is if the input for the OCR module is near perfect, then the OCR module will work as efficiently as required. So if the input to the OCR module is not that great, then the OCR module will fail more often than not. So the objective is to improve the pre-processing stage in this particular project. This is the basic block diagram of the LPR system. As you can see, there are a lot of stages here. Most of the stages here are pre-processing stages. Let's see one by one what each stage does. So we have an input image which is played with noise. We convert that input image into grayscale, and then we filter the image for Gaussian noise and salt and pepper noise using a medium filter of 3x3 window. So we have this input image here which is plagued with noise, and then after applying a medium filter we get this particular image. As you can see, the noise has been considerably reduced, but there are still some noise here and there which will be taken care of in the later stages. So next part is this edge enhancement. We enhance the edges using two methods, that is Sobel filter edge detection and morphological processing in MATLAB. So this defines the border really well, and which will be helpful for further stages. This is the output of the edge enhancement stage. Border clearing and enhancement of contrast. So contrast enhancement is done and borders are cleared. So there are some stray pixels in the previous images near the border. So this will be cleared, and the border of the characters are really well defined in this particular stage. This will help in template matching. The contrast of the whole image is also improved. Next, we extract the plate by removing the horizontal lines from the images. This is done using morphological processing. Also, the inside of the characters are filled. This is done because if we fill the inside of the character, the template matching will function really well. So in order to improve the efficiency of the template matching, we fill the inside of the characters. So after we fill it, we remove the stray pixels. As you can see in the previous image, there are a lot of stray pixels distributed around the image. Using the beware open function in MATLAB, we remove the stray pixels, and we now get a near perfect image to the OCR module. So the next step is character separation. We use the bounding box method here. So all the bounding boxes are considered, and we exploit a particular property of the number plate here to separate the characters. So as you can see, each character here is almost of the same width and same height. Using these properties, the bounding boxes which have the same y width and same x width are retained, and other characters are like, for example, this particular character which does not have the same y width or the x width when compared to the other characters is discarded. So using this particular property, the characters are separated, and then we get individual characters. The next step is template matching. So each individually separated characters are now matched with all the templates. When a template match occurs, that particular character is stored in a list, and when all the characters have been processed, this list is used as a string to retrieve the record from the vehicle. To retrieve the record from the database. So the next So the next stage is template matching. So in the template matching, the individual characters which were separated previously are matched to a template which are predefined. So in this template matching, when a match occurs, the character is stored. In the same way, all the characters are processed. When all the characters are processed, the number plate is pinged. Finally, when the character recognition module outputs the number plate string, we use this string to retrieve the record of the vehicle from the database. And this is as shown. This is a sample record of the sample number plate which we were seeing in the previous slide, and this is how the output should be. Let's move on to the demo now. So this is the MATLAB code which implements the ALPR system. And so the MATLAB code, as you can see, implements all the pre-processing stages here, and then finally it will get the number plate and open the vehicle record. So I'm going to hit run. So as you can see, when I hit run, there are a series of images that are displayed, and these are the outputs of every pre-processing stage. We'll look into it in some time. So this is the vehicle database. This is the vehicle record which is got from the vehicle database. As you can see, all the data and of the vehicle is here, and this particular number here AED632 is the same number as we were using in the image. So let's see each stage of the preprocessing stage here. First, the input image is played with noise. As you can see, there is considerable noise, and also there are some discolorations here in D and 6. This is removed using the median filter. So this is the output of the median filter here. Still there are some noise here which is removed in the next stage. And this is the output of the edge detection stage. A Sobel filter and morphological processing is applied to the previous image, and we get this particular image which is enhanced for the edges. And we clear the border to define the border really well so that the characters are recognized in a correct way. And we again apply a convolution filter to remove the noise and define the border really well. This is also a part of the edge enhancement. And then we fill the inside of the characters. So this filling is done as said in the presentation. The filling is done for efficient template matching. And this is the input image to the character recognition module. As you can see, this is near perfect. A, E, D, 6, 3 and 2 are all really well defined here, and the templates are also in the same way. So the template matching should give almost 100% hit, and which it does in this particular project. And so yeah, this is the input, and then we get it's an input for the character recognition module, and we get a output which is the vital record. So this is the project. So as you can see, this ALPR system mainly focuses on the pre-processing stage. The pre-processing stage is really important for the ALPR system, because if the character recognition module performs well only if the input to the character recognition module is almost perfect, and the pre-processing stage ensures that the character recognition module gets the input image which is near perfect. Hence, much of the study here is focused on the pre-processing stage, and we have been able to achieve good performance in spite of noise and light variations. Thank you very much.